Okay, this is the second volume question for simple surfaces or disks. The second question, which of course I'm going to let you do, and then once I give you an opportunity to complete the question, I will then work it myself. But look here, the region given is y equals negative x. We're only concerned about positive range values. And then also, we are worried about everything inside, not just y equals negative x, but also y equals 6 and x equals 0. And then you take that region, rotate it about the y-axis, get your volume. Find the volume of whatever shape is formed from that. I give you both formulas, but notice that you're going to have to graph this. At least graph the region, even if you don't graph the actual three-dimensional surface. If you can visualize it yourself in your head, or you just don't feel like you need to do that, then okay, but you're at least going to have to graph the region, so you have to do that yourself. Anyway, pause the video, try to do the problem, come back when you have an answer, or if you're just stumped. Okay, first of all, let's graph this. My graph looks like this. Yes, I had graphed it in advance, and now I'm just copying and pasting it. But that is what my graph looks like. So you take the line that you see here in the top graph, take the line, that's y equals negative x, only concerned about positive range values, and then you rotate that about the y-axis, and when you rotate it about the y-axis, you end up with this thing down there, which is a cone, right? This is a cone, or a circular pyramid, so to speak. And so, what's interesting is that, obviously, there is a formula, a pre-calculus formula for the volume of a cone, right? And that would get you the answer to your question. You could easily solve this by using the formula for that, but no, that's not what this assignment is about. We want you to all your teachers, if they were to give you a question like this, would be expecting you to use calculus. They would probably phrase the question in a certain way so that you would have to use calculus, and you couldn't just use the pre-calculus formula. Although the pre-calculus formula is a good way to check it, which I might do after this. But so you have to use one of the formulas here, one of the calculus formulas here, either vertically slice or horizontally slice, which those things should help us. So it says revolve about y-axis, so that means we're going to be using this one, the second formula for horizontally sliced. So, looking back at our graph of the three-dimensional cone here, we notice that if we were to slice it up, which in this case we're horizontally slicing it because we're revolving around the y-axis, and if we were to do that, then we have all these infinitesimally small slices, and the height is the height of these slices, so to speak, is dx, right? That's what, or dx, dy, however you want to put it. So the height, it refers to that, and then you just have to deal with the radius. Now, the radius is the only part that has to be considered. The radius is simply y equals negative x, isn't it? Just y equals negative x? Which, well, for one, we are using this formula, right? So this is the radius we're concerned with. What is the radius? The radius of either of these cylinders would simply just be, well, this would be the whole diameter. This would be the whole diameter. But we're only concerned about the radius. So the radius is simply just half of that. down to here. This is the radius, which the radius at any given point then is just given by the displacement, however, the displacement horizontally from the y-axis, which is x equals something. That's what our radius is equal to. Or x equals negative y, right? Because y equals negative x here, which if we convert that into x's, you have x equals negative y. So x equals negative y is our radius. The radius is usually just the function value, right? And according to the formula, it says that, well, I mean, it is a dx, sorry, not there. It is a dy here. So that means that whatever if we're going to plug in our function in for the radius, then that means that we're going to have to, it's going to have to be in terms of y, which in this case it is here, x equals negative y. So that's why this is the correct one, another way of arriving at that. So you're just going to use your function value, since this is a simple volume question involving disks. Just use the f of x function, and you need to be in terms of y because there's a dy there. So x equals negative y is the radius, and the width was dy, right? I think we can do this integral. So if I go to the next page, whoops, if I go to the next page, because I'm kind of running out of space, we have an integral. Oh, I'll get the limits situated later. But there's the pi r squared. R was negative y squared dy, right? And then the limits, getting the limits situated, which we can put the pi on the outside, which I'll do. But the limits, so, whoa. They want us to find the volume of the, all of this from a y standpoint, from the y coordinate standpoint, because this is dy, that means that a and b have to be y coordinates, right? That's something that I stress. Because there's dy, a and b have to be y coordinates. So, from a y coordinate, looking at this solid from a y coordinate point of view, at the bottom here, this is 0. At the top here, at the very top, that is 6. So you go from 0 to 6. How do you know it's 6? Because y equals 6. That's how you know. My graph was drawn with y equals 6 taken into consideration. So the top y value is 6. Bottom one is 0. Also x equals 0. Does it get written here? X equals 0. And at x equals 0, y would have been 0. Is another way of thinking of it. 0 to 6 for the integral. The pi's there on the outside. Negative y squared is simply the same as plus y squared dy, which you integrate, and in the end you get about 226, and that's your answer. So that is another example problem, another example of how to find the volume of simple surfaces. In other words, using the method of disks. Okay, there you go.